Okay, we're going to be looking at the segment addition postulate today. And basically what the segment addition postulate says is if we have a line segment and we have a couple of points on our line segment, let's call it A, B, and C, that if we add AB to BC, we will get the total, which is AC. So think of it as the parts add up to the whole. Okay, looking at our first example, we have a line segment here. Which is C, D, E, and CD is 9. The total of this is 20, and DE we don't know. Oh, make it a question mark. That's supposed to be a question mark there. So we don't know what that is. So what we can do is we can set this up as an equation and solve it. We know that CD is 9. DE, we don't know what its value is, so I'm going to just put DE in its place. And the total is 20. Now we just have a one-step equation that we need to solve for DE. So I'm going to subtract 9 from both sides. Cancel those out, and DE equals 11. And that's our answer. All right, let's look at example 2. For example 2, again we have a line segment that is DEF. So D is here, E is here, and F is here. All right, we know that the length of the whole thing is 8. We know that EF is 1. Again, what we don't know is, this part here, DE. So again, I'm going to set up an equation. Segment DE plus EF equals DF. Plug in what we know. We don't know DE. We do know EF is 1, and DF is 8. And all we have to do is subtract 1 from both sides, and we end up with DE equaling 7. And that is our answer. All right, those are numeric examples, but let's move on and look at our examples that have variables in them. So we have line segment JIH. So I have J here. I have I, and I have H. All right, this JI is 3x minus 2. 2. This is 10, and the whole thing is 6x minus 4. So what we need to do is we need to set up an equation. Now remember, the two pieces add up to the whole, so I'm going to start with my two pieces. I have 3x minus 2. I'm going to add to it the other piece, which is 10, and that is going to add up to the whole, which is 6x minus 4. So now what we need to do is we need to use our equation skills. So we're going to put our like terms together first. So I'm going to put together this negative 2 plus 10. So I get 3x plus 8 equals 6x minus 4. I'm going to subtract the 6x from both sides. I end up with a negative 3x plus 8 equals negative 4. I have to subtract the 8 from both sides. I get a negative 3x equals a negative 12. Divide by negative 3. And we get x equals a positive 4. And the problem was asking us to solve for x, so we're done. Okay, looking at our next example, same type of thing going here. We have our line segment, and that is F, G, H. FG is labeled as x plus 7. GH is labeled as x plus 14. And the whole thing is labeled as 13. So again, we're going to set up an equation with the two pieces equaling the whole. So I'm going to start off with FG, which is x plus 7. I'm going to add to it GH, which is x plus 14. And that's going to equal the total, which is 13. Just like on our last problem, we're going to use our equation skills to solve for x. So we're going to do x plus x gives us 2x. 7 plus 14 gives us 21. And that equals 13. We need to subtract the 21 from both sides. So we have 2x equals, that's going to be a negative 8. We're going to divide both sides by 2, and x equals negative 4. And since we're asked to find x in this case, we're done with the problem. All right, looking at our next example, we have the same thing going. We have a line segment that is DEF. DE is 2x plus 3. EF is negative 5 plus 2x. And the whole thing is 14. And again, we're solving for x, so we're going to set it up. We're going to start with DE, which is 2x plus 3. We're going to add to it EF, which is negative 5 plus 2x. And that's going to give us the total, which is 14. So now what we need to do is add our like terms together. So 2x plus 2x gives us 4x. 3 minus 5 is a negative 2, and that equals 14. Add 2 to both sides. We get 4x equals 16. And then we simply divide by 4 to solve for x, which gives us x equals 4. And again, that's what they were asking for in the problem, so we're done. All right, for our next one, we have a line segment, FED. So here's F, E is about right here, and here is D. So this is 5, ED is x plus 4, and the whole thing, FD, is negative 7 plus 3x. So again, we set up our equation, adding up the two pieces together. So 5 plus x plus 4 equals a negative 7 plus 3x. We put our like terms together. That gives us x plus 9 equals negative 7 plus 3x. add the 7 to both sides. Oops, my bad. Hang on. I usually like to start with my variables, so I'm going to go back and do that. So subtract 3x from both sides. You get negative 2x plus 9 equals negative 7. Subtract 9 from both sides. We end up with a negative 2x equals a negative 16. Divide by negative 2, and we get x equals a positive 8. And that is our answer. All right, for the last couple problems, we're going to focus on midpoints. And the thing we know about a midpoint is it splits our segment into 2 equal pieces. So for the next one, I'm going to draw a picture. The problem doesn't have a picture originally, but I'm going to draw one, and I recommend you do too every time you're given a diagram without a picture, or a problem without a picture. So we are told that M is the midpoint of PQ. So I'm going to draw that in. PM is 6x plus 7. MQ is 9x minus 8. And we need to find x. All right, what we do know about the midpoint is, again, it splits this into 2 equal pieces. So all we have to do is set these 2 pieces equal to each other, PM and MQ, and we can solve for x, because again, we know that they are the same length. So 6x plus 7 equals 9x minus 8. Subtract the 9x from both sides. 6 minus 9x gives us a negative 3x. Add our 7 equals negative 8. Subtract the 7 from both sides. We have a negative 3x equals negative 15. And then we simply divide by negative 3 and we get x is 5. And again, on this problem, we're only asked to solve for x, so that's the end of the problem. All right, let's do another one with midpoint. We are told that M is the midpoint of PQ again. So we have M as our midpoint, and then we have P and Q. PM is given as 5x plus 8, and PQ is given as 76, and we need to find x. All right, it might look at first like we don't have enough pieces in order to solve this equation, but remember, a midpoint splits this line segment into 2 equal pieces. So if PM is 5x plus 8, then MQ is also going to be 5x plus 8. So we're going to set up our equation. We know the 2 pieces, 5x plus 8 plus 5x plus 8 equals 76. We're going to put together our like terms. 5x and 5x gives me 10x. 8 plus 8 gives me 16. Equals 76. Subtract our 16 from both sides. 10x equals 60. Divide both sides by 10, and we get x equaling 6. And again, we were asked to solve for x, so we're done with the problem. All right, for our last problem, we are told that DE bisects AB at C. So let me draw that out for us. We have, I'm going to put it over the side so I have room to work. DE is bisected by by AB at C. So this is C and this is AB. Now, whenever something is bisected, it goes through the midpoint. So think of by as 2, so it splits it into 2 equal pieces. We're told that AC is 3x plus 22. We're told that CB, I'm sorry, I got that backwards. We're told that AC is negative 8x minus 23. CB is 3x plus 22, and we need to find x. So just like before, we've got a line segment that is split into 2 equal pieces. So we're just going to set those equal to each other in order to solve for x. So I have a negative 8x minus 23 equals 3x plus 22. I'm going to start off by subtracting 3x from both sides. Negative 8x minus 3x gives us a negative 11x. Minus 23 equals 22. We're going to add 23 to both sides. And hang on, something looks wrong on this problem. 8x minus, I see what it was. This wasn't supposed to be negative. Let's redo that equation. I am so sorry. So this was 8x, positive 8x minus 23 equals 3x plus 22. Again, I'm going to subtract my 3x from both sides. I get 5x minus 23 equals 22. I'm going to add the 23 to both sides. I get 5x equals 45. And finally, we divide by 5 in order to get our x, which in this case will be 9. And that is the end of our day 1 of segment addition notes.